This was a very basic thing that everybody knows. The interesting part here is this is why this concept becomes very necessary to understand. Now, this was just about the solar system. Now, imagine billions of galaxies present in our universe. ओके सो बहुत ही डिटेल में वी आर गोइंग टू अंडरस्टैंड व्हाट इज़ मैटर. मैटर क्या होता है, मैटर हम किसको कहते हैं. डेफिनेशंस में भी काफ़ी सारी ऐसी टर्म्स हैं विच स्टूडेंट्स डोंट अंडरस्टैंड यूजुअली, एंड वी आर गोइंग टू लुक अपॉन दैम, एंड मैं आपको एक ऐसे वे में समझाने की कोशिश करूँगा विच विल मेक मोर सेंस टू यू. एक ऐसी डेफिनेशन हम मैटर की तैयार करेंगे जिसमें कोई कन्फ्यूजन ना रह जाए, जिसमें कोई और डाउट ना रह जाए. सो लेट्स बिगिन विथ व्हाट इज़ मैटर एक्चुअली. लेट्स से मेरे पास ये पेन है, ऑल्सो मेरे पास ये कैप है. नाउ इन दोनों में से आपको क्या लगता है विच वन इज मोर हैवी और हैवियर? विच वन इज हैवियर? ऑफ कोर्स द पेन इज हैवियर. व्हाई द पेन इज हैवियर? बिकॉज it has something called as mass inside it. Correct? Now mass क्या होता है? Now we'll avoid going into a circular definition, and I will tell you कि मैं इसको circular definition क्यों बोल रहा हूँ. So अभी के लिए उसे avoid करते हैं. I will come on that. Okay. What is mass? I can say कि इसके अंदर कुछ material और let's say कुछ stuff, something is stuffed inside this pen which is making this pen heavier. I can compare it and say कि इस कैप में जो स्टफ भरा हुआ है, जो मटेरियल इस पेन में है, इट इज मोर देन द मटेरियल जो इस कैप में. करेक्ट? नाउ मास इज दैट स्टफ. साइंटिफिक लैंग्वेज में हम उसी मटेरियल को, जिस मटेरियल से ये सारी चीज बनी हुई है, उसी मटेरियल को, उस स्टफ को जो कि किसी भी ऑब्जेक्ट के अंदर होता है, उसे हम मास कह देते हैं. ओके. ऑल्सो वन मोर थिंग, लेट्स से दिस पेन इज लाइंग ऑन माई हैंड, राइट? अब ये पेन कुछ स्पेस ऑक्यूपाई कर रहा होगा मेरे हाथ में. करेक्ट? ऑफ कोर्स कर रहा है. नाउ इन साइंटिफिक टर्म्स, instead of calling it a space, we used to term it as volume. Okay, यही होता है volume. You might have learned about volume, that volume is nothing but the amount of space that an object occupies. So that is volume. So this pen and also this cap is also occupying some volume. So this cap, this pen, this table on which I am teaching, the laptop on which I am teaching, the device on which you are watching my lecture is occupying some space. And also, if you notice, they are also having certain mass, right? They are having certain material inside them, which is stuffed inside them, which is giving them this quality known as mass, right? This is the very definition of matter. Now we have discovered what is called matter. Let's say something which is having both mass, okay, let's say this pen, it is having a mass, also this is also having certain volume, इसलिए we call it that this pen falls under the category of matter. Now what I was trying to explain to you earlier, that I was avoiding a circular definition. Let's say, what is a circular definition? We say matter is something which has both mass and volume. Correct? But जब बच्चे पूछते हैं कि what is mass, so the usual definition is the amount of matter present inside an object is known as its mass. Now here comes the circularity which I was pointing out earlier. किसी भी चीज को मास कहने के लिए हमें मैटर बताना पड़ता है, एंड किसी भी चीज को मैटर कहने के लिए हमें मास की डेफिनेशन देनी पड़ती है. So this is the circular loop of information which carries on, and this is what creates confusion in the minds of student, and I'm trying to erase this confusion by not introducing you with the term matter in the first place in the definition of mass. What I taught you is mass is nothing but the material or the stuff inside an object, and matter is something which has mass and volume both. Now mass and volumes के साथ हम थोड़े experiment करते हैं. Let's say I am having a balloon, okay, and I am having a balloon which is empty, which is not inflated actually. This is an inflated balloon. Inflated means फूला हुआ balloon है. इसके अंदर कुछ हवा मैंने भरी है, एयर, एंड दिस इज एन एम्प्टी बलून, राइट? ओके, इतना समझ आ गया. नाउ you might have heard that if you take this balloon and weigh it, then it will weigh, let's say, 10 grams. Okay, and if you weigh this balloon, you will notice that it is actually weighing more than the previous balloon, let's say 13 grams. So why is this change? Because it has air inside it, and इससे हमें पता चलता है कि air के अंदर भी mass होता है. Correct? Yes, air also has mass. Now let's understand one more interesting thing. This was a very basic thing that everybody knows. The interesting part here is, let's say I have a balloon which I have blown through my mouth, which has, of course, what? Air in it. Correct? I have an empty balloon in which I haven't blown any air or any gas, and it is lying on the ground. Okay. Another case is I am having a balloon in which I have specifically filled helium gas. Now, there is an interesting case. What is the interesting case? We know that air or gas has mass. Correct? यही मैंने पढ़ाया आपको. एयर के पास भी मास होता है. We have seen here. Now the interesting thing is, if something is having more mass, correct? Let's say इसको हम A बोलते हैं. This situation is A, this situation is B, and this situation is C. Now the mass inside the balloon A is more than the mass inside the balloon B. Correct? Now what we notice is, let's say the balloon है वो आपने अपने मुंह से फुलाया है. Then tell me from your personal experience, आप उस balloon को कितना ही कोशिश कर लो हवा में उड़ाने की, it won't fly off. Ultimately वो balloon वापस लौट के ज़मीन पे आ ही जाएगा. Correct? क्योंकि वो आपने अपने मुंह से फुलाया है. क्योंकि आपने उसको अपने मुंह से फुलाया है, उसके अंदर भी एयर ही गई है. करेक्ट? मेजरली कार्बन डाइऑक्साइड गैस गई है, वी कैन सी. एंड इन द सराउंडिंग वी आर ऑल्सो हैविंग एयर. And in the surrounding we are also having air. Correct? Now what is happening is this balloon is not able to go up. Why? We'll come to that. Now let's see the second case. Here also the mass in the balloon B is less than the mass in the balloon C. Correct? क्योंकि इसमें तो कोई और गैस नहीं थी, इसमें तो कुछ भी नहीं था. This is an empty balloon, but here we have added the mass of a helium gas. Helium is a gas, it also has mass. But why does it rise up? ये बलून हीलियम वाला हवा में क्यों उड़ जाता है? Despite of having more mass than a balloon which is having no extra air, no filled air, filled with nothing, it is an empty balloon, then why does a balloon which is filled with something is going up? This is where we come to the concept of density. I want you to introduce with the term density here. What is density is that the amount of substance filled inside this balloon is more dense than the amount of substance present outside the balloon of the same volume. What I'm trying to say is, इस balloon का जितना volume है, okay, इस balloon का कुछ volume है, उतने volume में जितना matter और जितना mass इसके पास है, okay, that mass is way less dense than the mass of the same volume present outside it. I hope you are getting me. जितनी गैस इसके अंदर भरी हुई है, उस गैस का कुछ वॉल्यूम होगा. उतने ही वॉल्यूम की यदि आप सराउंडिंग की एयर लो तो इसकी डेंसिटी बहुत ज्यादा है कंपेयर्ड टू इसकी डेंसिटी. नाउ आई अंडरस्टैंड दिस इज अ टिपिकल कॉन्सेप्ट, सो मैं इसको एक और एग्जांपल से समझाता हूं. लेट्स सी कि मेरे पास एक बहुत बड़ा स्विमिंग पूल है, ओके, एंड उस स्विमिंग पूल में आई एम डूइंग एन एक्सपेरिमेंट. नाउ दिस इज द स्विमिंग पूल, दिस इज द वाटर सरफेस, ओके, this is the water surface I'm having. Now in this water surface, this will be the floor of the pool, right? This is the floor of the pool. Now what I'm experimenting is I am having three bottles. Okay, I am having three bottles and I'm sitting at the floor of the pool. Sorry. So I'm sitting at the floor of the pool and I'm having three bottles. Each of those bottles are very different from each other. In what way? Let's say एक बॉटल है जिसको मैंने पिचका दिया है पूरा, ओके, ऐसा करके मैंने उसको पूरा क्रश कर दिया है, एंड दैट बॉटल इज दैट बॉटल आई हैव प्लेस्ड हियर. Secondly, I have this bottle which is empty, but I have not crushed it. Okay, this is empty. There's nothing inside it. Thirdly, I am having a bottle, identical bottle hai तीनों. Now let's say this bottle is completely filled with water. Okay. In surrounding, what we are having, of course, swimming pool mein hai, so we are having a lot of water in the surrounding. Okay. We are having water in the surrounding. We are having water inside this bottle. Now, from your thinking, from your logic, apply your logic and tell me what will happen to this bottle if I place it on the floor and leave it. Yes, it will stay on the floor itself. Why? Because इसके अंदर पानी भरा हुआ है. And also the additional weight of the bottle, the plastic of the bottle, it is keeping it sunken at the floor. It is keeping it at the bottom of the swimming pool. Also, in the case of this bottle, I have not crushed it. That's why air is trapped inside this bottle. Correct? Now, what will happen to this bottle if I'll keep it here and then I'll leave it? Yes, this bottle will start moving upwards. This bottle will start to float, much like the balloon which we have seen in the first case, in which we have filled it with helium. Okay, now this bottle will also start to float. But what is in the case of this bottle? Now of course practically this is not possible, but hypothetically assume कि मैंने इसके अंदर की सारी air निकाल दी है and it is having nothing but vacuum. Okay, now what will happen to this bottle? Now, as it is having nothing inside it, just the vacuum and also the weight of this plastic, this bottle will also remain at the floor only. I hope this is clear. Now, the interesting part, much like the case which we have studied over here, what we see is the mass of C, the mass of B, and the mass of A. What is interesting over here is in this case, what is happening? Mass of C is greater than mass of B. Of course, क्योंकि इसके अंदर water है तो water में ज़्यादा mass होगा of course air से. That is why the lighter thing or the thing with less mass is floating upwards. Correct? But in this case, what is happening is mass of A is less than mass of B. Still, the thing with the more mass is floating upwards, and the thing with the less mass is kept down at the bottom. What is happening here is just because the fact of density. What happened over here is कि जो इसके अंदर जो चीज का मास था, इसके अंदर एयर थी, तो जो एयर थी उसकी डेंसिटी इसके सराउंडिंग में जो वाटर प्रेजेंट है उसकी डेंसिटी से कम थी. दैट्स व्हाई इट स्टार्टेड फ्लोटिंग अपवर्ड्स. वेदर कंपेयर टू दिस केस, इसके अंदर और कोई चीज थी ही नहीं, प्लस इसके अंदर सिर्फ क्या था, ये प्लास्टिक था, एंड ऑफ कोर्स प्लास्टिक इज अ सॉलिड, सो ऑफ कोर्स एयर एंड वाटर दोनों से ज्यादा उसकी डेंसिटी होगी. दैट इज व्हाई इट वाज सिंकिंग डाउन. And in this case, what was happening? The density of this water is exactly same with the density of this water. But due to the additional weight of this plastic over there, it was kept down. So I hope the concept of mass is very clear to you. So we have studied what is mass. Okay. Now due to mass, we are able to understand that something which has mass and also occupies some space, that is volume, is what we call matter. And we have also interrelated them with a concept called density, which is nothing but mass per unit volume. This is why this concept becomes very necessary to understand, because density is very closely related to mass and volume. I hope this is very clear. Now we'll move on to the next subtopic, which is states of matter. So what are the states of matter? So there are majorly three states of matter. Okay. What are the three states of matter? Haryana, Gujarat, and Uttar Pradesh. Okay, I was just kidding. What are the three major states of matter? We all know these are solids, liquids, and gases. Now, if I say, this is a very basic concept you guys all know, I'm not going to bore you guys in this. Rather, I will tell you something interesting. Let me ask you one question. If I say matter exists majorly, now mark the words which I'm using, majorly. Matter exists majorly in three states, which are solid, liquid, and gases. Is it true or is it false? So majority of you might think that this is a true statement, but let me tell you, this statement is actually false. Why this is false, I'll tell you. Let's understand what are solids, liquids, and gases first. What is solid, what is liquid, and what is gas? To understand the major difference between these three, we need to know about two concepts. One is shape, okay, and one is volume. Now, according to our understanding, what is shape? Shape is nothing but the orientation of the accumulation of particles of that substance, of the object. Okay. So what is shape actually? Shape means किस orientation की कोई चीज है. Orientation means किस position में उसके particles आपस में attached हैं. Let's say I am giving you 1,000 pieces of Legos. Okay. You have to arrange these Legos in a certain way that these creates different shape. Of course, you can make a building with Legos, right? You can make a car with Legos. Okay, ignore my drawing. The shapes I'm of the trying to explain you something. You can make different things with Legos. What is one major thing which is changing among these different things is that these are all of different shapes. These objects differ. That is majorly because of the fact that you have arranged these Legos in different orientations. You have arranged these Legos in different possible ways. You have arranged these particles in different ways that you are leading to different shapes of objects. Is this clear? Right? Now, we need to understand about shape. We got to know what is shape, that is in what orientation the particles of that objects are arranged. And next is volume. What does volume means? Is these shapes are occupying space. I have told you about volume. How much space do these objects or these things occupy is known as their volume. Now, to understand solids, liquid, and gases, we will need this information. Now, let me just put it aside and explain to you what is solid, liquid, and gases. To define solid, the major thing which I'll say to define solid is something which has shape and volume. Liquid will also have certain shape and volume, and gases will also have certain shape and volume. Now, what is the shape of solids? This is a solid, of course. This is a solid, of course. Now, what is the shape of this solid? How do we define this shape? We can say, sir, it is of cylindrical shape. Okay, मान गया मैं आपकी बात. This is cylindrical shape. We can also say, sir, this is pointing towards the end, this is a bit blunt towards the other end. If we try to define it this way, it will never end. You can define n number of things about the shape of this pen, that is, it is having certain and certain shape. But what is the most determining feature of this shape is this shape is very rigid, and this shape doesn't change very easily. Okay, so we can say the shape of solid is rigid, or let's say, for the lack of better words, we say fixed. Okay, in general layman language, we can say the shape of solids is fixed and the shape of solid is rigid. Next thing, we compare it to the shape of liquids. Is the shape of liquid the same? Let's say I'm having two things over here. I'm having this glass of water. Now the water inside this glass, I can't show you, of course, otherwise it will spill out. Now what I'm trying to say is the shape of water inside the glass is exactly the shape of the glass. If I pour it inside my mouth, the water will take the shape of my gastrointestinal tract. Correct? Now, this is of course a cleaning liquid, has no fixed shape. It is taking the shape of the container. Okay. Now it has taken the shape of the container upside down. Similarly, so what is the defining characteristic of the shape of liquids? That it is not fixed. Okay. I hope this is very clear. Now understand the same thing with the example of the balloon which I showed. We are having air in our surrounding. When we inhale the air, okay, when we inhale the air goes inside our lungs and it starts taking the shape of our respiratory tract. Okay, so we can say the shape of gases is also not fixed. Okay, this is the one thing that we have understood about the shape of different states of matter. Now ये पेन है and it is occupying certain space. Okay, volume is nothing but the occupied space. Now this pen is occupying certain space, and does the space which is occupied by this pen is changing? No. Means it also has a fixed volume. Correct? I can say that. Of course I can say that. लेट्स से मेरे सामने जो टेबल है, इट इज ऑक्यूपाइंग सर्टेन स्पेस. ऐसा तो नहीं है कल को ये टेबल ज्यादा स्पेस ऑक्यूपाई करने लगी एंड मेरा कमरा छोटा पड़ जाएगा. नो, राइट? सो बेसिकली आई कैन से कि सॉलिड्स जो हैं दे हैव अ फिक्स्ड शेप, ऑल्सो अ फिक्स्ड वॉल्यूम. करेक्ट? नाउ इन द केस ऑफ लिक्विड we have seen that the shape is not fixed, but the volume is fixed. How? Let's say I am having water. Okay, let's say there is 200 ml of water inside this glass. If I pour this 200 ml of water inside a bucket, okay, it will take a shape of merely a disc. Okay, in the water it was something like this, in the glass it was something like this. Let's say if I pour it into a bucket, it will become something like this. Okay, but this was 200 ml and this was also 200 ml. Did the ml change? Did the volume change? No, right? मैं किसी भी कंटेनर में वाटर को डाल दूं, the volume of the water, the volume of the liquid stays the same. We have studied in mathematics that the units we use to measure volume is nothing but liter, ml, or centimeter cube, etc. Now let's say this water is 200 ml or 200 cubic centimeters. Let's say I throw this water into any container of this universe. Will the volume of this water change? No. The water's volume will remain the same. That's why we say liquids have a fixed volume. Although they do not have a fixed shape, but they do have fixed volume. Now, let's come to gases. Let me teach you with an example. Let's say I am having a box. Okay. This is a cuboid box. Okay. It has certain length, certain breadth, and certain height. It is having an air inside it, or let's say helium gas inside it. Okay. Now this container or this box is having certain volume, right? Let's say the volume is x centimeter cube. I have another box over here which is slightly smaller than the previous one. Okay. What I try to do is the same amount of helium gas which is present inside this box, I try to transfer it into this one. And to my surprise, I'm actually able to do this, right? I'm actually able to do this. In the case of water, let's say I'm having this big glass, lassi glass, okay? So Punjabis don't get offended. Let's say I'm having this big glass. It is containing, let's say, 1000 ml of water, okay? If I'm having a normal glass over here, whose capacity is only 200 ml, will I be able to put the whole water inside it? Will I be able to put the whole water inside it? No. Why? Because the volume of this water is fixed, because it is a liquid. But in the case of gases, what happened? Gases do not have a fixed volume. I can take this gas from a size of a big container and surprisingly fit into a container which is much smaller than the previous one. And this property of gas is known as compressibility. Means I have compressed the gas. मैंने gas को compress कर दिया. That's why I was able to fit the gas inside a smaller container. This shows me what? That gases do not have fixed volume. Why? Because here the volume was x centimeter cube. Let's say here it was 0.5 x centimeter cube. तो मैंने गैस को आधा कम कर दिया, आधा कंप्रेस कर दिया. So the volume actually became half. मैंने इसका जितना वॉल्यूम था उससे हाफ वॉल्यूम 0.5 टाइम्स वॉल्यूम रखा यहाँ. और ऐसे समझ नहीं आ रहा तो यू कैन से here the volume was x centimeter cube, यहाँ मैंने x by 2 centimeter cube करा. Still I was able to put in the air or the helium gas which I have put it in the other container. This property of gas is known as compressibility, and this proves that gases do not have a fixed volume. So we can say that gases neither have a fixed shape, of course, and nor do they have a fixed volume. I hope this concept is very clear. Now let's come back to the question which I have asked you in the starting. This one. Does matter exist majorly in the three states of solids, liquid, and gases? So the answer is no. Why the answer is no? Because now I'm going to introduce you with two more states of matter. One is plasma, another one Bose-Einstein condensate, और BEC for short. ये दोनों क्या होती हैं? Let's understand. What is plasma? Now in our next class we'll see कि how do we change the states of matter. तो उसमें हम देखेंगे. For now just see this is when we have solid and we have to go to liquid. Let's say हमारे पास ice है. Then in order to go from ice to water, from solid to liquid, we have to heat this. Correct? यदि मैं इसको और हीट करूं वाटर को तो क्या होगा? वाटर विल स्टार्ट बॉइलिंग, ऑफ कोर्स. उससे क्या होगा? ये वाटर स्टीम बन जाएगा, वाटर वेपर में कन्वर्ट हो जाएगा. दिस इज नथिंग बट गैसियस स्टेट. व्हाट इफ आई डोंट स्टॉप देयर? व्हाट इफ आई कीप हीटिंग इट फॉर thousands of degrees of Celsius? Then what will happen? If I increase the temperature by thousands of degrees of Celsius, then we'll reach a state which is known as plasma. What I have told you from the analogy of the Lego bricks, let's say we are having a solid structure which you have made from the Lego bricks. Okay, when we heat them, what happens? These particles which make our matter, we'll understand them in the near classes. What happens that these start to dissociate, these start to break down. What happens, we get a liquid from solid. Further, if we keep heating it, keep providing it energy, then they scatter even more, and what we get is a gas. What I do, if I increase the temperature but by so much that even these particles start to break down. We are not going into the technicality of this, but what is happening over here is the temperature or the energy is so massive that it is breaking the particles also. Because of the destruction of these particles, we reach a state of matter which is known as plasma. Now, I will tell you why this question's answer was false. Because matter is majorly, I told you to mark my words, matter is majorly found in a state called as plasma. Now, you might be surprised that why plasma? Until and unless I'll give you an example, that is our sun. I hope अब ये थोड़ा सेंस बना रहा होगा, right? Why? Because if you compare the mass of the sun to the mass of the entire solar system, it is much, 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 much greater than the entire solar system. So the mass of the sun is so massive that it outweighs our entire systems thousands of times, and the sun is entirely made up of plasma. Inside the sun, the temperature reaches so high that the molecules, the atoms, the particles starts to break, and that gives the massive energy to the sun. Now this was just about the solar system. Now imagine billions of galaxies present in our universe, billions of stars present in our universe, they all are made up of plasma. So you can clearly see the most abundant state of matter is nothing but plasma. Now let's come to Bose-Einstein condensate. What is Bose-Einstein condensate? Let's see. So this state of matter was actually given by two scientists, which is very evident from the name itself, which are, of course, one is Albert Einstein, okay, and the other one Satyendranath Bose. These two scientists introduced us to the state known as Bose-Einstein condensate. Now, to understand this, let's imagine our classroom. Let's say this is our classroom. What happens at the normal conditions? The conditions are normal. It is a chill weather. It is a very decent weather. Students are happy. Teachers are happy. Everybody is happy. Students are roaming here and there, talking to each other, changing seats, of course, eating lunch, looking outside the window and stuff. Okay. What will happen if I turn on all the ACs? Now things will start to get cold. Okay. Students will try to move less. The movement will quiet down. Similarly, if I keep decreasing the temperature and I make the whole classroom freezing cold, then of course everybody will just freeze in their own situation, right? Kind of similar happens with atoms, with the particles of matter. We'll know what is atoms. Let's understand. Kind of same happens with the particles of matter, the Lego bricks which I was talking about. Okay. This thing never happens with humans, never happens with real life people, but happens with the particles of matter, especially with the particles of gas. What happens is, let's say you have a container in which you have a gas. These are the particles of gas. You keep cooling it to just above what is known as absolute zero. And absolute zero is something कि जिसके नीचे और कोई टेम्परेचर एग्जिस्ट नहीं करता है. दिस इज द कोल्डेस्ट टेम्परेचर एवर पॉसिबल. ओके, इसके जस्ट अब हम रखते हैं क्योंकि एब्सोल्यूट जीरो पे पहुंचना इज नॉट दैट प्रैक्टिकली पॉसिबल. ओके, इसके जस्ट अबव जब हम किसी गैस को रखते हैं, then the particles start to condense. That is why it is known as condensate. The particles try to condense and behave and stick to their own positions. They don't move. In normal conditions, what is happening? Like I told you in the classroom, particles move rapidly in and around over here and there. But in freezing cold conditions, in the temperatures as close as possible to absolute zero, what happens? These particles stop moving and these particles synchronize perfectly and try and tend to behave like one single particle. This whole thing becomes one single particle. How can you understand this? Let's say we are having an orchestra. Okay, or one better example is, let's say we are having a kavali. You might have heard kavali. Kavali is a music form. What happens in kavalis, in the background there are several people who clap, right? They clap, and their claps are so synchronized. Means these claps are so much in sync that it almost sounds like there's only one person which is clapping. Correct? In reality, 8 people are clapping, but they are clapping so synchronously, they are clapping so much in sync, they are clapping so much simultaneously that it almost sounds like one single person is clapping. You don't hear 8 different claps, you hear one single sound of one clap. That is very similar to what happens here. These particles try to behave so synchronously that it behaves like a single atom as a whole. Now I hope this is very clear to you all. Now in the next